Chapter 9, The Anatomy of the Iris, from Wolff's Anatomy 8th edition, page number 308. Now coming to the part 2 of the anatomy of the iris, that is the macroscopic appearance of the iris. Macroscopic appearance of iris. Anterior surface. The anterior surface of the iris is generally richly textured, but in the darker races where iris pigment is increased, the surface is smooth and velvety and the texture is masked. Collarette. The collarette consists of a series of tubercular forming a sometimes interrupted circular ridge. It lies about 1.6 mm from the pupillary margin and divides the surface into an outer ciliary zone and an inner pupillary zone, which often differ in color. The iris is slightly thickened at the collarette, 0.6 mm, which overlies an incomplete vascular circle, circulus vascularis iridis minor. The vascular connection between the minor circle and the tunica vasculosa lentes, that is posteriorly placed, disappears before birth, but a remnant pupillary membrane may be present at birth and is frequently seen in premature babies, where it is a confirmation of a gestational age. Fuchs crypts. The iris surface has a tubercular structure which is most exaggerated in the pupillary zone and collarette region, where there are deficiencies in the superficial layers. Large pit-like depressions are termed as Fuchs crypts. So Fuchs crypts are nothing but the large pit-like depressions on the anterior surface, and these are peripheral or central. So central are larger, and at periphery there are smaller crypts, and these are best seen during the examination of the anterior angle by gonioscopy. In blue eyes, especially in children, the peripheral perforated zones are seen as dark rings near the iris root. The collarette and crypts appear after birth. So, the collarette and crypts, they appear after the birth. Pupillary ruff. The posterior epithelial layers of the iris extend forward at the pupillary margin at the pupillary ruff. So, pupillary ruff is nothing but the extension of the posterior pigmented epithelial layer near the pupillary margin. They don't extend on the anterior surface of the iris as such, but just extend at the pupillary margin so that they are visible on the slit lamp examination, or with the naked eye they are visible. So this pupillary ruff, and it has the crenations, and these crenations result from a forward extension of the radial folds of the posterior iris surface. So posterior iris surface has got radial folds, and these radial folds are seen as crenations of the pupillary ruff, that is the extension of the anterior pigment epithelial cells at the pupillary margin. The ruff marks the anterior limit of the embryonic optic cup. Iris sphincter. In blue irises, or where the stroma is atrophic, the iris sphincter is visible as a buff colored. Buff color is nothing but the pale yellow color. Flat circular strap-like muscle, 0.75 mm wide, encircling the pupil. The central part of the ciliary zone is smooth, but peripherally, several contraction furrows occur concentric with the pupil, which deepen as the pupil dilates. There is less pigment at the base of the furrow, which is best seen in a dark iris with a small pupil. Fuchs. In the ciliary zone, there are radial streaks which are straight, with a small pupil and wavy when it is dilated. With a slit lamp microscope, it is possible in blue irises to see the epithelial layers of the iris, which appear as copper-colored line in the slit film. Deep to the stroma, the color is due mainly to pigment in the posterior epithelial layer. Color is lacking in albinism or overlying a cyst of the epithelium. So, the color iris is hypopigmented, or there are no pigments in the iris in albinism, or hypopigmented when there is overlying a cyst of the epithelium. And the color of the iris is mainly to pigment in the posterior epithelial layer, where posterior epithelium is displaced backwards in case of the overlying cyst and separated from the anterior epithelium. So cyst is in between the anterior and the posterior epithelium. There is a space separation. So posterior surface. The posterior surface of the iris is dark brown and smooth and displays the following radial and circular furrows. Sharpest contraction force. Numerous small folds extend radially from 1 mm from the edge of the pupil because the posterior pigmented layers extend forward around the pupil. These folds are responsible for creating appearance of the pupillary margin. Sharpest structural furrows. These involve both epithelial and vascular layers. They begin 1.5 mm from the pupil margin. These are sharpest structural furrows where they are narrow and deep but become shallow and broaden towards the peripheral iris. Towards the center, these are narrow and deep, and towards the periphery, they become shallow and broadened. Uh, they pass into the valleys of the ciliary processes. There are valleys of the ciliary processes, so into these valleys, these sharpest structural furrows pass. Circular furrows. Fine circular furrows cross the structural furrows at regular intervals and are due to variation in the thickness of the pigment epithelium. So these circular furrows are because of the variation in the thickness of the pigmented epithelium and the arrangement of the stroma into ridges with the furrows between. The furrows are incomplete. They are least developed behind the sphincter and most developed at the iris root. These furrows, circular furrows, are incomplete and these are most developed behind the sphincter pupillae muscle and the most developed at the iris root. So towards the center these are least developed and towards the periphery, that is towards the iris root, they are most developed. These are the circular furrows, and the high proliferative capacity of the epithelial cells in this region may account for the frequency of pigmentary cysts here. Pits. Distinct pits are found scattered over the pigment epithelium and represent desmosomal structures in the posterior epithelial layer. Now diagrams or figures. Composite drawing of the surfaces and layers of the iris, beginning at the upper left and proceeding clockwise. The iris cross-section shows the pupillary A and ciliary portions B, and surface view shows a brown iris with its dense, matted anterior border layer. Circular contraction furrows are shown arrows. In the ciliary portion of the iris, Fuchs scripts C are seen at either side of the collarate in the pupillary and ciliary portion and peripherally near the iris root. The pigment rough is seen at the pupillary edge. The blue iris surface, pupillary HD, the blue iris surface shows less dense anterior border layer and more prominent trabeculae. The iris vessels are shown beginning at the major arterial circle in the ciliary body E. Vertical branches of the arteries and veins extend towards the pupillary region. The arteries form the incomplete minor arterial circle F, from which branches extend towards the pupil, forming capillary arcades. The section below it demonstrates the circular arrangement of the sphincter muscle G and the radial processes of the dilator muscle. The posterior surface of the iris shows the radial contraction furrows I and the structural force J of Charbin. Circular contraction folds are also present in the ciliary portion. The pars plicator of the ciliary body is at K. Now figure 9.2, the normal iris. The normal iris, so there is a collarate which is a zigzag line and it is the thickest portion of the iris. It is around 0.6 mm thick, and towards the iris root it is thinner and it is around 0.5 mm in thickness. So the anterior surface of the iris is divided into two portions, ciliary portion and the pupillary portion by the collarate, and it is a zigzag line, and it is nothing but, this is the prominent trait, and it is because of what? It is because it overlies the incomplete minor artery arterial circle. Now, outer ciliary zone and inner pupillary zone. So, this diagram is about the anterior surface of the iris, two portions, and the collar zigzag line. Then, figure 9.3, diagram showing the structure of the iris. The retinal layer appears at the edge of the pupil. Retinal layer appears at the edge of the pupil, that is posterior pigmented epithelium, which corresponds to which layer of the retina? Posterior pigmented epithelium. Posterior-most pigmented epithelial layer of the iris, it corresponds to which layer of the retina? It corresponds to the neurosensory layer of the retina. And the retinal pigment epithelium, it corresponds to which layer of the retina? It corresponds to the anterior epithelial layer of the iris, which is pigmented, but it is less pigmented than the posterior pigmented layer of the iris. This is very important because both the layers of the epithelial layers of the iris are pigmented, anterior and posterior. But we use the posterior pigmented epithelial layer because the posterior epithelial layer is more pigmented than the anterior epithelial layer, and the pigmentation is lost towards the periphery, where it becomes continuous with the non-pigmented epithelial layer of the iris and neurosensory layer of the retina posteriorly. So, here's figure 9.3. Diagram showing the structure of the iris. The retinal layer appears at the edge of the pupil, where it forms the pigment border P. The mesodermal layer is separable into deep layer DM, running from the root of the iris to the pupil, and superficial layer SM, the axial limit of which forms the collarette, are periphery of iris PR. Posterior retinal layer, the crypts of the iris situated in the ciliary portion, may be considered as openings distributed in the superficial mesodermal layer anterior. So, there is superficial mesenchymal layer and deep mesenchymal layer. Superficial mesenchymal layer, it extends from iris root to the collarette, and the deep mesenchymal layer, it extends from the ciliary border iris root to the pupillary edge. So this diagram is all about that. Now another figure 9.4. Surface anatomy of the front of the iris. Surface anatomy of the front of the iris. So anterior surface of the iris with the naked eye, how it looks. The anterior surface is divided into two parts by the collarette, that is a zigzag line. It is a ridge that overlies the minor arterial circle, that is incomplete. This zigzag collarette, it is thickest portion of the iris. It is 0.6 mm towards the periphery. The iris gets thinner, and at iris root, its thickness is 0.5 mm. Okay. So, collarette divides the iris anterior surface of the iris into two parts: ciliary zone, outer zone, and pupillary zone, that is towards the center, towards the pupillary edge. So, these are the two portions. So, you can see the crypts which are peripheral and central also, in the ciliary zone also, and in the pupillary zone also. You will see the pits. These are the small or the large depressions. Now these depressions are present. These are larger towards the center, and towards the periphery these are smaller. This is what this book is telling. Then these are the crypts. Then there are contraction furrows. These are the circular furrows. Okay. On the ciliary zone you can see. And you can see the pigmentera, that is the extension of the posterior pigmented epithelial layer at the pupillary edge, but it doesn't overlie the anterior surface of the iris. So that was about the figure 9.4, showing the surface anatomy of the front of the iris that is seen with the naked eye. Now figure 9.5, meridional section of crypts of Fuchs. Meridional section of the crypts of Fuchs. You can see here. Fuchs crypts is present peripherally and centrally, that is in the pupillary zone also and in the ciliary zone also. In the ciliary zone towards the root, these are smaller, and towards the center, these are larger. You can also see the sphincter pupillae muscle which is present in the stomach. Now, the figure 9.6. Varieties of human iris: A. Deeply pigmented type, B. Medium European, and C. Blonde European. So you can see the brown eye, black, brown, black eye, A, that is heavily pigmented, B, that is medium European eye, that is less pigmented and very less pigmented, or medium pigmented and very less pigmented in figure C. It is seen in the blonde or European eyes. Composite picture to show arises of various colors and mesodermal texture. So figure A, you can see here, you can see the colorate two zones. You can see the pupillary rough. Okay, you can see the radial streaks. Again B, it is slightly colored. You can see the colorate. Again figure C, that is magnified view. And figure D, magnified view. You can see the colorate, zigzag line. Now figure 9.8, scanning electron micrograph of the colorate region of the anterior iris surface showing a branching vessel of the minor circle of the iris and small crypts of fuchs. Okay, so arrowhead here showing the crypts of fuchs, these are the small depressions, and the branching vessel of the minor circle of the iris. The colorate overlies the minor circle of the iris, which is incomplete. Now figure 9.9, the pupillary membrane at both developmental abnormalities of the second edition. Okay, so pupillary membrane, actually it is not seen in fully newborn babies, full-term babies, and when it is present in premature babies, it confirms the gestational age. And even when it is present, even after the birth in full-term babies, it usually spontaneously disappears after the birth. And when it fails to do so, and it is coming in the pupillary axis even before the 1 year, and causing the obstruction to the light rays falling in the retina, and causing the problem in normal development of the eye and the brain, then after the birth, then we should go for either laser membranolysis using Q-switched NDR that I have already discussed in previous part. You can see that part, and then surgical removal, membranectomy. Okay, so that was about figure 9.9, the pupillary membrane, remnants of the pupillary membrane. These are the vessels in the pupillary area, we can see. Now figure 9.10, brown iris showing a prominent pupillary rough arrowhead. Here you can see the pupillary rough. It's nothing but the extension of posterior pigmented epithelial layer at the pupillary margin, but it doesn't extend onto the anterior surface of the iris, because when it does so, it is called as a condition that is known as iris ectropia. Figure 9.11, blue iris to show the sphincter arrowhead underlying the posterior mesodermal layer. Blue iris to show the sphincter arrowhead underlying the posterior mesodermal layer. Okay. Figure 9.12, iris cyst. The two layers of the iris epithelium are separated by a fluid so that the posterior surface of the posterior pigmented epithelium is visible at the pupillary margin. But you can see the loss of those crenations here in case of the iris cyst. Iris cyst is nothing but a fluid accumulation between the two layers of the iris which are separated, and the pupillary rough, actually it has the crenated margins, and it becomes more obvious in case of the iris cyst, and you can see the crenations are not there on the pupillary rough. This posterior pigmented epithelium is very obviously seen, and with lots of crenations near the pupillary edge. So yeah, that was all about the microscopic appearance of anterior surface of the iris. Tomorrow in part 3 we will discuss about the layers of the iris from anterior to posterior layer, and there are four. First is anterior border layer, second is stroma and sphincter muscle, third is anterior epithelium and dilator muscle, and fourth is posterior pigmented epithelium. So another way to classify the microscopic structures of the iris are anterior limiting membrane or anterior border layer. Then second is stroma containing sphincter, dilator, pupillary muscles, vessels, nerves, and collagenous tissue. Then third is epithelial layer, anterior epithelium and posterior epithelium. Both are pigmented, but the posterior pigmented epithelium is mentioned as a pigmented epithelium because it is more pigmented than the anterior epithelium. So we will discuss them tomorrow in detail, and the microscopic appearance, I guess, will be covered in another 2 or 3 parts. Yeah. So thanks for listening to me patiently. Here I conclude this part. Bye.